Hello, Rimda and Ali. Good evening, both of you.
Good evening, ma'am.
Good evening. So let's wait for Lubna and Utsia, then we will start the session. Okay, so I think everyone has joined the class. So let's start. Okay, so in the last class, we have completed all the characteristics of the transition elements, right? So there are 12 characteristics. Please just go through all the characteristics and all the trends. Okay, and the exceptions are very, very important because the question may be asked from the exceptions part. Okay, so just be careful, just revise those topics. Okay, so let's move forward now. So the next topic is, yes, Lubna.
Sorry, ma'am.
So, some important compounds of transition element. So, in your syllabus, there are two compounds of transition element. First one is the compound of chromium, which is potassium dichromate, K2Cr2O7. Okay, potassium dichromate. And the second one is the compound of your manganese. Okay, so when manganese make a compound with your potassium and oxygen, so it's a potassium permanganate. So there are two compounds in your syllabus. So we have to discuss its method of preparation, its chemical properties, its uses, etc. Okay, so let's see one by one. First is your K2Cr2O7, potassium dichromate. Okay, why it is known as dichromate? Because chromium here is 2. Okay, so that's why dichromate. So first see method of preparation, how it is prepared. So dichromate, potassium dichromate is prepared from chromite ore. Okay, now what is chromite ore? So chromite ore is FeO dot Cr2O3. Cr2O3. Okay, when you combine this, so you can write FeCr2O and 4. Okay, so this is your chromite ore, FeCr2O4. Okay, now see, the potassium dichromate is prepared from this chromite ore in 3 steps. In 3 steps. First step, there will be a conversion of chromite ore to sodium chromate. Okay, this chromite ore, which is FeCr2O4, it will be converted to sodium chromate, which is Na2CrO4. Okay, so when you see this reaction FeCr2O4 plus Na2CO3, right? Sodium carbonate. Plus, when you give the oxygen O2, so it will give you Na2CrO4, which is sodium chromate, plus Fe2O3 plus CO2. So this is a redox reaction. This is a redox reaction. Oxidation plus reduction हो रहा है यहाँ पे. Okay, and you can see when you check oxidation किसका होगा, because you know very well chromium, this C3 to Cr2O7, it's a good oxidizing agent. Okay, it's a strong oxidizing agent, and oxidizing agent are those agent which oxidizes others but reduces itself. Okay, so what will happen, chromium का यहाँ पे reduction होगा. Okay, chromium reduction होगा and other uh, like other thing का वहाँ पे oxidation होगा. That's a redox reaction where oxidation and reduction takes place. Okay, now see, this is 7 upon 2. This is a balanced chemical equation, right? So 7 upon 2. So when you, this is your 2. Okay, so to remove 2, when you multiply each and every compound with 2, so you will get this equation. So it will give you 2 to the 4, FeCr2O4 plus 8 Na2CO3 plus 7 O2. So it will give you Na2CrO4. Okay, this is your main product. So that's how chromite ore is converted to sodium chromate. That's the first step. That's the first step. Now see the second step. So there will be a conversion of sodium chromate. This sodium chromate will be converted to sodium dichromate. Sodium dichromate. So again, there will be redox reaction. So in the acid, when you do the acidification reaction, okay, when you add acid to sodium chromate, so it will give you sodium dichromate. Okay, Na2CrO4, this is a sodium chromate. When you treat this sodium chromate with acid, which is H2SO4, so what happens? This is a good dehydrating agent. Okay, H2SO4 is a dehydrating agent. So what will happen? So from here, water will be released out, water will be removed out, and you will get Na2Cr2O4, which is sodium dichromate plus Na2SO4. Okay, sodium sulfate. And this is your main compound. This is your main compound. Is it clear, everyone?
Yes, ma'am. Yes, ma'am.
See the last step, the conversion of sodium dichromate to potassium dichromate. So once you get the sodium dichromate, this is Na2Cr2O7. So what you're supposed to do, you just add KCl. Okay, say KCl. So now tell me which type of reaction it is. Which type? Na2Cr2O7 plus KCl. So it will give you potassium dichromate. So this is a double displacement reaction. You can see sodium. Sodium has been replaced by potassium. Okay, and it will give you K2Cr2O7. Okay, and here this sodium यहाँ पे क्या हो रहा है? This sodium will replace this potassium and this potassium. Okay, and that's how you will get NaCl plus your K2Cr2. So this is a double displacement type of reaction. Okay, so again, let's see 3 steps. So method of preparation is 3 step preparation. Steps first step is chromite ore to sodium chromate. Okay, it's conversion of chromite ore to sodium chromate. After that, sodium chromate will be converted to dichromate when you add H2SO4. Okay, next step will be when you get the sodium dichromate, what you're supposed to do, just add KCl and you will get a double displacement type of reaction will occur and you will get potassium dichromate, which is K2Cr2O7. That's the main product. Okay, ये हम prepare कर रहे थे and you will get a NaCl, a salt. So that's the method of preparation from chromite ore, which is FeCr2O7, O4. Okay, so you have to start the reaction from this. Okay, and at last you will get this potassium dichromate. Any doubt in these 3 steps?
No, ma'am.
Ali, Rimda, Kutsia? Any doubt, बच्चों?
No, ma'am.
Okay. Okay, so next, see, this is important. This one is important. So pH dependence of dichromate. So how dichromate depends on the pH. Okay, so pH means basically here the color dependence की बात करेंगे हम. Color dependence on pH. So you can see in alkaline medium, see this is a reaction CrO4 2 minus, CrO4 2 minus, it is in equilibrium, right? So in the forward reaction, you can see when you add acid, when you add acid, so in acidic medium, this chromate ion, it will be converted to dichromate. Okay, and in basic medium, this dichromate in alkaline solution, like what is alkaline solution? When the pH is greater than 7. When the pH is greater than 7, so this dichromate will convert into the chromate. And this chromate, see, there is a color change. So chromate ka color kya hota hai? It's yellow in color. The solution you will get is yellow, and this dichromate solution is orange in color. Okay, so when you decrease the pH, when you decrease the pH means in acidic condition, in acidic solution, the pH is less than 7. Okay, like 1, 2, 3, and so on. Now, so in acidic condition, this CrO4 2 minus chromate ion, this is your chromate ion, CrO4 2 minus. Just memorize this. So this in acidic condition, what happened? This chromate ion will convert into the dichromate ion. Okay, and this dichromate ion, basically this dichromate solution is orange in color. So you will get yellow से क्या होगा? Convert हो जाएगा solution in orange. Okay, in acidic condition, in acidic medium. Now see the backward reaction. When this dichromate ion, when the pH is greater than 7, means alkaline solution. When you give the alkaline solution any base, so what you are supposed to do, basically you will get a chromate ion which is yellow in color. So your solution will convert into the yellow color. So if the solution changes its color from orange to yellow in the presence of a base, so just what was, so here the production or the formation of CrO4 will be there, right? CrO4 2 minus. So just remember, in alkaline solution, like when the pH is greater than 7, orange color of your Cr2O7 2 minus, which is a dichromate ion, changes to yellow color. Why it changes its color? Due to the formation of your chromate ion. Your chromate ion. Got my point?
Yes, ma'am.
So here you can write on the reaction also. This K2Cr2O7, potassium dichromate. The potassium dichromate, basically its color is orangish red. Okay, or reddish orange, you can write orangish red. So in basic medium, suppose you just add potassium hydroxide. The potassium hydroxide is base, right? So in alkaline medium, so it will form a chromate ion. It will form a chromate ion, means it will form K2CrO, which is yellow in color, potassium chromate. Okay, so potassium dichromate will convert into potassium chromate plus water, plus water. So that's the reaction. That's the reaction. And here, what is, when this K2Cr2O7, it will dissociate, so it will form K plus and Cr2O7 2 minus. That was the dichromate ion. And here, this K plus and CrO4 2 minus. Okay, so this is your chromate ion. So just remember the color. Your chromate, potassium chromate is yellow in color, but potassium dichromate is orange in color. Okay, and the interconversion, just remember this. Okay, so just write on this point. So Cr2O4 O7 2 minus, which is a dichromate ion, in basic medium converts to chromate, okay, which is CrO4 2 minus, which has yellow color. Okay, and just write on this reaction. Okay, now let's see this question. When, see this question, when FeCr2O4, FeCr2O4 is fused with Na2CO3, Na2CO3 in the presence of air. So it gives a yellow solution of compound A. Okay, so let's see step by step, we will solve it. So FeCr2O7, okay, plus, so when it is fused with sodium carbonate, which is Na2CO3. So this type of question can come in your case-based type of question. Okay, case-based. टाइप के क्वेश्चंस में पूछा जा सकता है. सो Na2CO3 के साथ when you combine this, so see what is this reaction. We have already done this. So this is your FeCr2O4 is nothing, it's a chromite ore, right? So when you add this chromite ore को जब आप Na2CO3 के साथ treat कराते हो तो you will get Na2CrO4. Okay, Na2CrO4. So that is a, yeah, Na2CrO4. That's the A compound. That is your A compound. And it gives a yellow solution. This is a yellow solution. This is a, according to question, this is a yellow solution. Why it is a yellow solution? Because here you can see this again forms a chromate ion. CrO4 2 minus. And chromate ion का color क्या होता है? So it's a yellow color. Okay, CrO4 2 minus chromate ion color क्या होता है? It's a yellow color. So that's why Na2CrO4 has a yellow solution. It's a yellow solution. Next, so compound A on acidification gives compound B. Now tell me, when compound A, this Na2CrO4, on acidification, when you add acid, कि जब आप H plus ion दोगे, so it will be converted into compound B. What will be the compound B? Yes, just think about it. In acidic condition, in acidic medium, this chromate ion will convert into, yes,
Dichromate ion.
yes, dichromate. Very good. So dichromate, so sodium dichromate here. So Na2Cr2O7, right? So this is the compound B. In acidic condition, this chromate ion, this is a chromate ion, CrO4 2 minus. So it will be converted into dichromate. So sodium chromate था ये, तो यहाँ पे क्या बन जाएगा? Sodium dichromate. You can check here. This is ion Cr2O7 and 2 minus. This is your dichromate ion. Okay, and you will get a orangish color. This is the orange color solution. Okay, clear till here?
Yes, ma'am.
Okay,
Yes,
next
ma'am.
step, compound B. This compound B on reaction with KCl. Now, who will tell me? When this compound B react with KCl, so what will be the product here?
KCr2O7 plus
K2?
NaCl.
Yes, K2Cr2O7. Okay, no need to write down the byproduct here. Okay, so K2Cr2O7. Okay, this is your compound C. Now, next sentence, read it. An acidified solution of compound C oxidizes Na2SO3 to D. An acidified solution of compound C means the K2Cr2O7 acidified solution means when you add acid means आप H plus ion दोगे. Okay, means H plus ion you can write down the H2SO4. So when you add H2SO4, so it will become acidic potassium dichromate solution. Acidic potassium dichromate solution. So an acidified solution of compound C will oxidize this Na2. ये क्या करेगा? It will oxidize this Na2SO4, SO3, sorry. So it will oxidize this Na2SO3 to D. And what is D? Who will tell me what will be the D over here? It's very easy. Just think about it. It will oxidize too. So what is oxidation? Addition of oxygen, right? So what here? Because this is the acidified solution, so ये क्या कर रहा है? This will convert this Na2SO3 to Na2SO4, right? And you know very well what is oxidation? The addition of oxygen is oxidation, right? So here one oxygen will add up here, and it will give you Na2SO4. So this is your compound D. Is it clear to everyone?
Yes,
Yes,
ma'am.
ma'am.
Okay, so this is your Na2SO4, that's the D. So A A, B, C, and D. Okay, and if you see the last this reaction, so you can write on the balanced chemical equation. So when this K2Cr2O7, when you add H2SO4, so it will form acidified solution of potassium dichromate. After that, when you add Na2SO4, SO3, so what happens? This K2Cr2O7 plus H2SO4 acidified solution of potassium dichromate is a strong oxidizing agent. So it will oxidize this Na2SO3 to Na2SO4 plus byproduct will be your Cr2SO4 whole thrice plus K2SO4 plus water release over. Right? Why water will be released? Because this H2SO4 is a dehydrating agent. ये क्या करता है? Dehydration करा देता है and the water will be released here. So this is the whole reaction. Balanced chemical. This is not balanced. You can balance it. This is the reaction when the Na2SO4 oxidizes to Na2SO4 in the presence of K2Cr2, acidified K2Cr2. So that's the whole reaction. Okay, but in this question, they just ask you the D compound. So you just write down Na2SO4. Okay, so that's the oxidation product of Na2SO3. Okay, next. Now let's see the structure of Cr, chromate and dichromate ion. What's the structure of chromate and dichromate ion? This is again important. Now see, this is a chromate ion, CrO4 2 minus. CrO4 and here the 2 minus. So this is the structure and it is yellow in color. So chromium, here it will be double bond oxygen, double bond oxygen. So it's again a tetrahedral type of structure. Okay, so you can draw either this or this. So chromium here, oxygen, oxygen, oxygen. So it's you can check the hybridization. So hybridization of chromium is sp3. So sp3 hybridized chromium it is. And in the bracket, you can write on this and 2 minus. So that's how this is CrO4 2 minus. That's the structure of chromate. Now, what about the dichromate? So when two chromate ion combines together, okay, so this is your CrO3, here CrO3, and when it combines with other CrO3 by this oxygen linkage, so this is your dichromate ion. Dichromate, two chromate ion linked together via this oxygen linkage, right? So you can see this is a chromium, 3 oxygen here, oxygen, okay, chromium and other 3 oxygen. So, and here charge will be 2 minus. Why 2 minus? Because again, Cr2O7 2 minus it is. Okay, dichromate ion. उस पे charge क्या होता है? 2 minus. Now see the bond angle, sorry. This is the bond angle between this, see, chromium, oxygen and this chromium. Okay, these two bond. इन दोनों के बीच में जो bond angle होता है, it's 126 degree. 126 degree, right? And yeah, this bond length of chromium and oxygen, this is 179 picometer. This is 179 picometer. So that's the structure of dichromate ion. And again, here the chromium hybridization will be sp3. sp3 for both the chromium. Okay, so that's the structure of chromate, okay, and dichromate ion. If in your exam, they just ask you the structure, so you can draw this structure. Okay, next one is your chemical properties. Chemical properties of potassium dichromate. So potassium dichromate and sodium dichromate both are strong oxidizing agent. Both are strong oxidizing agent. So it will, in any reaction, it will used as an oxidizing agent. And in a primary, see, volumetric, and have you done the volumetric analysis in your school, in your laboratory? Anyone?
Yes.
Titration, have you done?
Yes, ma'am.
Okay. So why potassium dichromate is used as a primary standard? in volumetric analysis? Do you know why it is used? Okay, see. So in titration, we use potassium dichromate as a primary standard, or you can say as an oxidizing agent. Okay, why? The question is why we use potassium dichromate as a primary standard. So it is a highly pure substance. Okay, it is a highly pure substance होते हैं and it is stable in air. It is stable in air. It doesn't change its oxidation state. So it is very stable. Okay, and it is basically non-hygroscopic. And now what is non-hygroscopic? So it does not absorb moisture. It does not absorb moisture. And ये जो होता है potassium dichromate, so we can weigh it accurately because of high molar mass. So these some properties, due to these some properties, we use this potassium dichromate as a primary standard solution, because primary standard solution are those solution whose stability won't change, oxidation state won't change. Okay, and they basically they are pure substances. So this potassium dichromate is a highly pure substance. So that's why we use it as a primary standard in the titration or in the volumetric analysis, you can say. Okay. Okay, see. So potassium dichromate and sodium dichromate are strong oxidizing agent. Okay, and sodium dichromate basically is a highly soluble. It is highly soluble in water and it is used as an oxidizing agent. So these two, potassium dichromate and sodium dichromate, both are highly soluble and they are used as an oxidizing agent. Okay. So here you can see Cr2O7, okay, which is your chromate ion. See, because we are just saying that oxidation, this is a strong oxidizing agent. So what is oxidizing agent? So which oxidizes other element or atom, but reduces itself. खुद को क्या करता है? Reduce करता है. And according to you, what is reduction? So reduction is basically, what is reduction? Who will tell me? No one? Yes, Rinda, tell me what is reduction? If I say T2Cr2O7 is a strong oxidizing agent. So it will oxidize other, but it will reduce itself first. So it will when I say it will reduce itself, so what does it mean? What will be what will change in the oxidation state? Whether the oxidation state will increase or decrease. Anyone? Okay, no issue. So see, if I say reduction, so what does this mean? So it will reduce. It means it will gain electron. It will gain electron. Okay. So it's oxidizing. Basically, its oxidation state क्या होगा? अगर हम gain बोल रहे, gain of electron means oxidation state will decrease. Right? Oxidation. Suppose here. Now, who will tell me in this Cr2O7, what is the oxidation state of chromium? What is the oxidation state of chromium here? This is 2 minus. Yeah. Let me know. You know how to determine the oxidation state. Yes or no? Hello. Lubna, do you know, बच्चे, how to determine the oxidation state? If you don't know, just let me know. No?
No, ma'am.
Okay, so no problem. At least respond. I'm just asking you again and again. At least respond to karoge aap. Okay, so let's understand how to determine the oxidation state. If you know how to find down the oxidation state, then only you can understand the redox reaction. Okay, so see, this is your Cr2O7 minus, right? So according to, so we know that K2Cr2O7, it's a strong oxidizing agent, right? So here the basically what is the ion over here? So it is a Cr2O7 minus ion. Okay, the cation is K plus potassium, K plus, and this Cr2, this is your dichromate ion. Okay, so what? So this is a oxidizing agent, a strong oxidizing agent. So it will oxidize other को oxidize करेगा, oxidize, but it reduces itself. But it reduces itself. It reduces itself means it will gain electron. It will gain electron. And if it is gain होता है तो उस पे क्या charge आता है? Okay. So suppose if there is a plus 6. Okay, suppose here the oxidation, how you will find out the oxidation state? So जिसका हम find करते हैं, this is your unknown, so let it be X. So how many atoms are there? 2 atoms of chromium are there. So you will write 2X plus how many atoms of oxygens are there? 7. And the oxidation state of oxygen is -2, which is equals to the total charge on this ion. So what is the total charge on this ion? 2 minus. So -2 charge. Now solve this equation. So 2x plus minus minus 7 to the 14 equals to -2. So 2x is equals to -2 plus 14. So 2x will be equals to plus 12 and x will be equals to plus 6. So what is the oxidation state of this chromium here? Plus 6. For both the chromium, there are 2 chromiums. For both the chromiums, oxidation state is plus 6. So here, this plus 6 oxidation से chromium क्या कर रहा है? It just changes to plus 3 oxidation state. So chromium 3 plus. So it means that here the chromium oxidation state is plus 3. Okay, so plus 6 say it just converted into plus 3. Okay, so here what happens? There is a gain of electron. Okay, so gain of electron for in the positive form, because here plus 6 से plus 3 में convert हो रहा है, तो here the gain of electron हो रहा है, right? Gain of electron, that's why plus 6 से plus 3. So if the gain of electron happen, means when the reduction happens, the oxidation state reduces. Oxidation state will reduce to plus 6 to plus 3 for the chromium. It means chromium का क्या हो रहा है? Reduction हो रहा है. And here you can see what is reduction. So reduction is the addition of electron. So यहाँ पे chromium Cr2O7 2 minus plus 6 आप add कर रहे हो. You are adding electrons. Okay, so adding electron means there is a gain of electron. If it is a gain of electron, it means reduction. So here the chromium की क्या हो रही है? Reduction हो रही है. Now understand my point?
Yes, ma'am.
Is it clear? Rimda, Ali?
Yes, ma'am.
Okay, so that's how we just calculate the oxidation state. Okay, next. Okay, so chemical property. So first, so this potassium dichromate is used to oxidize iodine ion to iodine. So this potassium dichromate, potassium. Okay, now let's see this. Okay, so here you can see what is, yeah, oxidation of iodine ion to iodine. So what is iodine ion? So iodine ion means I minus. So it will oxidize. So what is oxidation? So oxidation is removal of electron, loss of electron. Okay, Oxidation is loss of electron. So what here? I2. So it will convert to I2 plus 2 electron will be lost. Okay, just balance this equation. So 2I minus, it will be converted to I2 plus 2 electron. Okay, so here you can see there is a loss of electron, means यहाँ पे क्या हो रहा है? Oxidation. Okay, now you know very well because you are using potassium dichromate. So potassium dichromate is a strong oxidizing agent. So it just oxidize this iodine ion to iodine, but itself it will reduce. Suppose this is your Cr2O7 2 minus ion. This is your Cr2O7 dichromate ion. So this dichromate ion, it itself will reduce. And what is reduction? The addition of electron. So when you add electron, so it will give you 2Cr3 plus. Again, this reaction you will write. So here you can see again, plus 6 से plus 3 में convert हो रहा है, means oxidation state decreases. So this is the oxidation reaction and this is the reduction reaction. Okay, and both, when you combine both the reaction, you will get a redox reaction. Okay, reduction plus oxidation reaction. Okay, now see how you will write on the combined reaction or combined balanced reaction. So this is 6 electron, right? So in the first equation, in the oxidation equation, you have to make it same. So when you multiply it by 3, so you will get 3 to the 6I minus, and this is your 3I2 plus 6 electron, 6 electron. Now write down this equation, Cr2O7 2 minus plus 6 electron will give you 2Cr3 plus. Now what you are supposed to do, this and this will cancel out. Okay. Okay, this thing we are supposed to do in the previous, I think we have learned this in the 10th or 11th standard. Okay, how to write down the redox reaction and balanced chemical reaction. So when you just, this will be cancelled out and you will get 6I minus plus 6 Cr2O7 2 minus, okay, which gives you 3I2 plus 2Cr3 plus. Okay, and this happens in the basically in the acidic conditions. Okay, so what at the last, what we are supposed to do, we have to check how in the last step this reaction. Just a second. Yeah, this I2, let me rub this. Okay, now check it. Total number of electrons. How many total number of electrons are there? So here six electrons minus 6, right? So this is the coefficient, right? And here the minus charge is there on the iodine, so it will be minus 6 plus. And how many charge on this chromate ion, dichromate ion? So it will be minus 2, right? So when you add these, अब दोनों ही add करते हैं on the right side as well as on the left side. So this is minus 6 and this is minus 2. Combinedly, they will give you minus 8. Similarly, here, this is, you know very well, I2, it's a molecular form, so its oxidation state is 0. Its oxidation state is 0. And what is the oxidation state of this? So for this is a chromium 3 plus, and there are two coefficients, so you will multiply it and you will get plus 6. Okay, so here 0 plus 6, so you will get plus 6. Okay, now combinedly this your minus 8 and basically, yeah, and plus 6. Okay, basically you will get minus 6. Yeah. So when you combine this, 8 plus 6, so it will give you 14. 8 plus 6, so it will give you 14. So what you are supposed to do at last, see, first you will add the oxidation state in the right side and as well as in the left side. Okay, and when you combine the oxidation state of both, you will get some number. So here you will get minus 8 minus 6, it will give you 14. It will give you 14. 6, 12 plus 2, so it will give you 14. So for 14, you will just add 14 H plus ion. Okay, to balance this equation, so you will write 14 H plus ion on the right side of this arrow. And here you will, to balance this equation, you will write just half of this. Half of this, like 14 hai, to aap kya likhoge? 7H2. This is 7H2. So this is the combined balanced chemical equation, balanced redox reaction. This is the redox reaction. At last, you will get this reaction, and this is your redox reaction. Okay, so how you will get this redox reaction? By the oxidation of iodide ion to iodine. Okay, in the presence of potassium dichromate. So potassium dichromate basically is a strong oxidizing agent. So it will oxidize the iodine ion to iodine. Okay, and itself it will reduce. खुद क्या करेगा? Reduce हो जाएगा. Okay, and when you just combine these two reactions, you will get this. Is it clear? You everyone have done this redox reaction and balanced chemical reaction in the previous class, I think class 11th and 10th में आपने पढ़ा है ये. Is there any doubt?
No, ma'am.
Okay, if there is no doubt, then do this question. Second one. So this is the, basically we are just doing the chemical properties of the potassium dichromate. First property was when it helps in the oxidation of iodide ion to iodine. Okay, and that's the balanced chemical reaction and balanced redox reaction. Now, what about this? It will also help in the oxidation of Fe2 plus ion to Fe3 plus. Okay, now just do this. It's very easy. Step by step. Oxidation of Fe2 plus to Fe3 plus. So first step क्या करोगे आप? Again, Fe2 plus, it will oxidize to Fe3 plus electron. Oxidation is basically the removal of electron, loss of electron, right? So here loss of one electron will be there and you will get Fe3 plus. So this is the oxidation reaction. Okay, ये क्या हो रहा है? Oxidation reaction. And now what about the chromium? Again, you will write the same thing. Cr2O7, 2 minus plus 6 electron, and it will give you 2Cr3 plus. Okay, that's the reduction reaction. That's the reduction reaction. Now, what you're supposed to do, you have to make this first equation. Okay, basically you have to make it same as 6 electron. So what you are supposed to do, because here only one electron is there and हमें ये क्या करना है? This will be cancel out. Okay, so what you are supposed to multiply it by 6, okay, to get the same. So when you multiply this equation, first equation, oxidation equation with 6, so you will get 6 Fe2 plus, it will give you 6 Fe3 plus 6 electron. Okay, now write on this. So just add these two. Sorry, not this one. Yeah, the 6 electron and 6 electron will cancel out and you will get this equation 6 Fe2 plus Cr2O7 2 minus. Okay, and here on the right side, you will get 6 Fe3 plus 2 Cr3 plus. Now, the next step will be just add the oxidation state. Here, what will be the total number of electrons here? Okay, so Fe पे क्या charge है? 2 plus. And the stoichiometric coefficient over here is 6. So 6 2s are 12 plus 12. Here, what will be the overall charge? Minus 2. Minus 2. And here, what is overall charge? Plus 3, but here the coefficient. So you have to multiply it by 6. So it will give you plus 18. And here, 3 and 3 2s are 6. Okay, so when you add these two, you will get plus 10. Okay, and here when you add these two, you will get plus 24 electron, 24 electrons. And when you add, basically after that, you have to just right side से आपने इसे क्या करना? Subtract कर देना. So when you subtract this 24 electron minus 10 electrons, so you will get 14. You will get 14. So what you are supposed to do here on the left side of this arrow, you have to write 14H plus. 14H plus. Okay, and on the left side, sorry, right side of this arrow, you have to just, this will be half. Okay, 7H2. Water लिखना है आपने, and this 14 है तो just half of this 14 you have to write this. So that's a balanced chemical equation and balanced redox reaction. That's how you will write down. Is it clear now? Yes or no? If there's any doubt in any step, you can just ask me to repeat. Yes, Ali, Rimdha, Qudsiya, Lubna.
No, ma'am.
No, ma'am.
Okay. So similarly, just that's your homework. You will write down the oxidation of tin 2 plus, Sn2 plus to Sn4 plus. Similarly, oxidation of H2S to S. Okay, these two applications, these two chemical properties you will write. Okay, just a step by a step. First, you will write down the oxidation reaction of this Sn2 plus to Sn4 plus. Okay, after this, you will write down this reduction. The reduction to the same hoga. Okay, the reaction of the reduction will be same. After that, you will just multiply by a suitable number to make these two equation equal. Okay, like 6 electrons है तो यहाँ भी 6 electrons होने चाहिए, तो you have to multiply it by 6 to make these two equal, so that this 6 electron will cancel out and you will get a equation. Okay, the combined equation. After that, at last, you have to check the basically the oxidation state. Okay, total number of electrons you can say in all the or in either on the right side of this arrow or the left side of this arrow. After that, when you calculate, after that you have to subtract this right side से अपने left side को subtract कर देना है. What you get, just add that much type, that number like 14. If you get 14, so you will add 14H plus ion on the left side, and the half of this you will write on the right side in a water form. Okay, water में आपने subsequent ये coefficient क्या लगाना है, just half of this H. Okay, if it is 14, so you have to write down 7 over here. So that's the balanced redox reaction. Okay, just remember here the oxidation of Fa2 plus occurs, Fa2 plus oxidized to Fa3 plus. And here the Cr2O7 2 minus reduced to Cr3 plus. Okay, so reduction किसका हो रहा है, Cr2 chromium का. Okay, so chromium plus 6 से plus 3 में convert हो रहा है, and here the oxidation state of Rn, which is Fa2 plus, has been increased to Fa3 plus. Okay, so in the oxidation, the oxidation state increases. Okay, oxidation state increases, but in the reduction, the oxidation state decreases. Okay, just keep this in your mind. Next, okay, let's see the uses. So this K2Cr2O7 potassium dichromate is used as an oxidizing agent in volumetric analysis. Okay, it is also used in dyes. Dyes में हम use करते हैं, right? And we just use this in leather industry, photography में just for the hardening of the film. Okay, third application or uses is it is used in chromyl chloride test. Have you heard this test earlier? Chromyl chloride test. Okay, so chromyl chloride test in organic, it is a test or analytical method होते हैं which is used to detect the presence of chloride ion, Cl minus ion, okay, in any sample. So here this potassium dichromate is used, okay, and concentrated sulfuric acid हम use करते हैं, which produces basically a orange or reddish color के fumes of the chromyl chloride. Okay, so if the chloride ion agar present hota hai, so they just here you will see the fumes of orangish red color. Okay, and which is the fume of chromyl chloride. Okay, so here you can just say that the test is positive and the chloride ion is present in that compound, right? So potassium dichromate is used in the chromite chloride test to detect the presence of a chloride ion in any sample. Next use is it is used in the cleaning glassware, right? ये glasswares जो होते हैं हमारे उसको भी यूज क्लीन करने के लिए हम यूज करते हैं. So major use is it is also used in cleaning glasswares. So these are some uses of potassium dichromate. Clear everyone?
Yes, ma'am.
Next is potassium permanganate. KMnO4, KMnO4 potassium permanganate. Now, how potassium permanganate is formed? So first is method of preparation. Method of preparation of potassium permanganate. So potassium permanganate is basically prepared using two methods. First method is from the pyrolusite ore. From the pyrolusite ore. And what is pyrolusite ore? MnO2. MnO2 को हम क्या कहते हैं? Pyrolusite ore. So first preparation, write down along with me, from pyrolusite ore. Potassium permanganate is prepared. And what is pyrolusite ore? So MnO2 is known as pyrolusite ore. Okay, so how you can prepare? What is the reaction? So MnO2 plus in a alkaline medium. ये reaction जो होता है, it occurs in the alkaline medium. Okay, so KOH, potassium hydroxide plus O2. So it will give you a green color compound, which is K2MnO4. K2MnO4. It's a green color compound. Green color compound. This is not a potassium permanganate. Okay, potassium permanganate is KMnO4 plus water. So first step is it will give you a green color K2MnO4. Next step, when see this is what is this? So this is a K plus and MnO4 2 minus. MnO4 2 minus. So when you take this magnate ion MnO4 2 minus, this is a magnate plus in the acidic medium, in acidic condition, H plus ion दे रहे हो आप plus 4H plus ion. So you will get 2 MnO4 minus plus MnO2 plus H2O plus H2O. Now here you can see this MnO4 is nothing. It's a potassium permanganate. Okay, it's a magnate ion. It's a magnate ion. इसमें आप K add कर दोगे तो it's a potassium permanganate. Okay, KMnO4. MnO4 minus. It's a magnate ion. Magnate ion. Right? So that's how we just prepare the potassium permanganate using pyrolusite ore. Okay, pyrolusite MnO2 से आपने starting करनी है reaction. Add KOH okay, as a base, alkaline medium and plus O2. So it will give you a green color compound plus water. So this green color compound is, it will dissociate to form MnO4 2 minus. So you will take this MnO4 2 minus. Okay, so it will give you Mn O4. So in acidic condition, when this compound is compound में जब आप acid डालोगे, so you will get manganate, potassium permanganate. Potassium permanganate. Is it clear?
Yes,
Okay. Now see the second method.
ma'am.
Second,
Uh,
yes.
ma'am, in the second reaction, we got manganate iron, not potassium permanganate.
Yeah, so this is same, बच्चे. You can add here. You can write down. This is MnO4 2 minus. 2 minus है, it means इसके साथ क्या होगा? It will have K2MnO4. K2MnO4. That's why it will dissociate to form K plus and this 2 will be MnO4 2 minus. That's the KMnO4. आप यहाँ पे ये भी लिख सकते हो like K2MnO4. You can take this also. Plus when you add H2SO4 or any acid H plus condition में, तो you will get KMnO4. You can write down the whole reaction. Same thing. Okay. Yeah, I have written the ions only. Okay, this is the same thing. Okay, you can write on this reaction. When you take K2MnO4. After this reaction, you can just put the any acid and you will get, this will acidify and it will give you a potassium. So you can write K2MnO4 plus any acid, H plus medium में it will form KMnO4 plus your water, or no need to write on the byproducts, you can write on this. Okay, so KMnO4, potassium manganate. Okay, next method. Second method is commercial method. Commercial method. First method was KMnO4 is prepared from pyrrolysite ore, which is MnO2. Okay, so commercially it is prepared again by pyrrolysite ore. When the pyrrolysite ore here is fused with potassium hydroxide and oxidized with air, और KNO2 आप लेते हो, suppose. So basically, commercially, it is prepared by alkaline. You can write down. It is prepared by alkaline oxidative fusion of MnO2. Okay, followed by, first you will do the oxidation, and after that you will do the electrolytic oxidation. Electrolytic oxidation of manganate ion. Yeah, so see the step. So first step of this reaction is you just take MnO2, okay, and you will fuse. It is fused with KOH, okay, and oxidized with air or KNO. Okay, so you will get here MnO4 2 minus manganate ion. Second step, magnate, this is a magnate ion. Second step क्या होता है? You will do the electrolytic oxidation. Electrolytic oxidation. So when you do the electrolytic oxidation of MnO4 2 minus, you will get MnO4 minus. And what is this? This is a manganate ion, right? MnO4 minus. So this is a, what is this? This is a permanganate ion. So this manganate ion, it will convert into the permanganate ion. Okay, so this is a permanganate ion, and permanganate ion किसका होता है? This is your potassium permanganate. KMnO4. KMnO4 as the potassium permanganate. So commercially, how potassium permanganate is prepared? So it is prepared in a alkaline oxidative. First, you will do the alkaline oxidative fusion of your pyrrolysite ore, which is MnO2, and which is followed by the electrolytic oxidation of manganate. Okay, so you will get a permanganate ion. Second method. Third method of preparation is laboratory method. Laboratory method. So in your labs, how you can prepare the manganate ion? Permanganate ion, sorry. So Mn2 plus plus S2, this will. So S2O8. S2O8 के साथ आप react कराते हो in the presence of water. Okay, so you can write on the balanced chemical reaction plus 5S2O8 2 minus. So it will give you 2MnO4 minus plus 10SO4 sulfate ion plus your 16H plus. So that's the reaction. It's again a redox reaction. Okay, so that's a laboratory method. That's a laboratory method. Just learn this reaction. So Mn2 plus manganese, which is in +2 oxidation state, when it combines in S2O8, okay, this molecule in the presence of water, so it will be converted into the permanganate ion. Okay, and plus the byproducts are 10SO4 2 minus and 16 or any acid. Okay, H2SO4 to H2SO4 you can write HCl and acid, so H plus 16H plus. So that's the laboratory method. Next, write on the properties. Properties. Yeah. So potassium permanganate, potassium K2MnO4. So what is K2MnO4? Potassium manganate. Okay, K2 अगर है तो it is a magnet, and if it is KMnO4, so it's a permanganate. So K2MnO4 color, its color is basically green color. So green in color. But what about the potassium chromate, which is, sorry, potassium manganate, KMnO4. So K2MnO4 is a potassium manganate. Potassium manganate. Okay, and this is your potassium permanganate, KMnO4. Potassium permanganate. So what's the color of potassium permanganate? So it's purple, dark purple. बहुत ही intense color होता है इसका, dark purple. Okay, so the color of potassium magnate is green, and but the potassium permanganate is purple in color. Okay, so see this reaction, this KMnO4, when you heat this potassium permanganate, when you heat this permanganate, so it will convert into the potassium permanganate will convert into the potassium manganate, which is K2MnO4. Plus you will get pyrrolysite ore plus O. Okay, so that's the when you give the temperature. So when you in a when you give some heat. Okay, so this potassium permanganate, which is purple in color, it will convert it into a green color substance, which is a potassium permanganate. Sorry, manganate. Potassium manganate. Okay. So in you can check here this KMnO4, the oxidation state in KMnO4, the oxidation state of this manganese is +7. Okay, the +7 is oxidation state. What does this mean? So write down in KMnO4, the oxidation state of manganese is +7. +7. So what does this mean? So when you write down what is the atomic number of manganese? 25, right? So write down the electronic configuration. So it's argon 4s2 and 3d5. So what will be the oxidation state? Mn7 plus. So 2 from here and 5 from here. It will be removed. Okay, so it is Mn7 plus ion. So it's argon. The electronic configuration becomes the noble gas electronic configuration. Mn7 ki electronic configuration will equals to the argon electronic configuration. So in Mn7 plus, there is no unpaired electron. No unpaired electrons. Okay, so Mn7 means it is MnO4 minus. So in MnO4 minus ion, there is no unpaired electron. There is no unpaired electron. You can check here. So deep purple color. So you can write down why the color of MnO2. Okay, sorry, why the color of KMnO4, potassium manganate. Okay, it's dark purple. Why it's dark purple? So it's due to this deep color, this deep purple color. This is important. This point is important. Why question directly can come like why potassium manganate KMnO4 has intense deep color. So deep purple color, write down, of KMnO4 is not due to DD transition in not due to DD transition, because DD transition तो होगा ही नहीं, because in MnO4 you can the oxidation state of manganese is +7, and you have seen here the Mn7 has no unpaired electron. Okay, and we have learned that the transition elements form colorful compounds due to the unpaired number of electrons. But in KMnO4, the oxidation state of manganese is +7. Okay, and +7 में क्या होता है? There is no unpaired electron in the manganese. So why its color is intense purple? Okay, because the white होना चाहिए, right? The color should be white, but why it's intense color, intense purple color, deep purple in color? So it is not due to the DD transition. It is not due to the DD transition. The reason is rather it is due to the charge transfer. It is due to the charge charge transfer charge transfer from oxygen. Okay, from this oxygen of KMnO4 to manganese. So you can write here in the bracket ligand to metal charge transfer. Why there is an intense deep color of KMnO4? Okay, because it has no unpaired electrons, so it should be white in color. So why it's a deep purple color? So it's not due to the DD transition, because DD transition होगा ही कैसे? Because there is no unpaired electron. Okay, so in the it is due to the ligand to metal charge transfer. So here the charge transfers from ligand to metal, means from oxygen to manganese, the charge transfers. That's why the KMnO4 has intense deep color. Got my point?
Yes.
Okay, let's see the structure. So this is a magnet ion, structure of magnet ion. Again, it shows a tetrahedral type of a structure. O minus. This is magnet ion. MnO4 minus, 2 minus. MnO4, 2 minus. And this is a permanganate. MnO4 and only 1 minus. So this is a permanganate. Permanganate. So both have the tetrahedral structure. Okay, but you can see there are 3 MnO double bond. Okay, 3 MnO double bond and only 1 MnO single bond in permanganate. But in manganate there are 2 manganese and oxygen bond, double bond, 2 double bond and 2 single bond between the manganese and oxygen. Okay, so that's the difference between these two. Next, see the chemical properties. Yeah. So chemical properties, first, it it is again both are good strong oxidizing agent, both KMnO4 and potassium dichromate. Okay, potassium permanganate and potassium dichromate both are strong oxidizing agent. So chemical properties means first point write down oxidizing nature. It show the oxidizing nature in acidic condition. In acidic medium, it oxidizes. It show the oxidizing nature. Okay, so what will be the reaction? So it's a permanganate ion, means MnO4 only 1 minus charge plus, because it's a oxidizing agent, so again it will reduce itself, and if it is reduced itself means there will be a addition of electron. So 5 electron, so it will give you Mn2 plus. Mn2 plus. Okay, so here first reaction. So it will oxidize iodine minus to I2. Again, the same reaction will be there. Okay, so instead of dichromate ion, you will write down this MnO4 minus. The reaction will be the same. See the redox reaction which we have learned here, which we have discussed here. Yeah. Oxidation of iodide ion to iodine. So the reaction will be same. Instead of this reaction, reduction reaction Cr2O72 minus this reaction, you will use this reaction, this manganese reaction. MnO4 minus plus 5 electrons. So it will give you Mn2 plus. Got my point?
Yes, ma'am.
Yeah, so both have the same, both are equally oxidizing agent, a strong oxidizing agent. So again, it will oxidize this iodine minus iodine ion to I2. Second, it will oxidize to Fe2 plus to Fe3 plus. The reaction will be same. So instead of Mn chromium reduction reaction of chromate ion, you will write down this. Okay, oxidation reaction of permanganate. Okay, ion. See, yeah, one more thing, oxalate or oxalic acid. This potassium permanganate, it will oxidize this oxalate ion or oxalic acid to carbon dioxide. So what is oxalate? Oxalic acid. So oxalic acid is this COOH and COOH. This is your oxalic acid. Okay, and oxalate ion basically क्या हो जाएगा? This H plus you will remove. This is your CO. This is the oxalate ion. This is your oxalic acid. So this potassium dichromate, no, so potassium permanganate, it will oxidize this oxalate ion or oxalic acid to carbon dioxide. Okay. Next is your again H2S2 sulfur. It will convert and nitrite, nitrite to nitrate will convert. It will also convert the nitrite to nitrate. So what is nitrite? Nitrite ion is NO2 minus and it just convert this nitrite ion to nitrate. So nitrate is NO3 minus. Okay, nitrite is NO2 minus and nitrate is NO3 minus. Then one more thing, it will convert this sulfite ion to sulfate. SO3, 2 minus to SO4, 2 minus. So these are some chemical properties of potassium permanganate. Okay, and you can, you know the trick how to write down the redox reaction, so you can easily write down. Next is your now the oxidizing nature. Yeah, this was the oxidizing nature in acidic medium. Second point, write down the oxidizing nature in basic medium. Oxidizing nature in basic or neutral medium. Neutral medium. In neutral or basic medium, again, it will oxidize some ions, like for example, and yeah. So here, what will be the reaction will be something different. So MnO4 minus, again, so it's यहाँ पे भी reduction होगा. So here the number of electron will be different. So it will convert this to MnO2. MnO2. Now see some example. Let's check it out. So in the basic or neutral medium, this potassium permanganate, it will reduce this I minus. See, if the medium is acidic, so this potassium permanganate will oxidize this I minus to I2 in the acidic condition. But if the condition is basic, so it will convert this I minus to IO3 minus. Okay, means iodide ion, say it will convert this iodide ion to iodate. Iodate. Okay, this is important. Just see the difference between these two. Okay, so in the acidic medium, this same thing, this iodide ion will convert into the iodine, I2. But in the basic medium, basic condition, so it will convert this iodide ion to iodate, which is IO3 minus. Got my point?
Yes, ma'am.
Second example, see, if it is S2O3 2 minus. S2O3 2 minus. So what is S2O3 2 minus? So it is thiosulfate. So thiosulfate. Thiosulfate ion को किसमें convert करता है to sulfate. So in basic medium, potassium permanganate will convert or oxidize this S2O3 2 minus thiosulfate ion to sulfate ion. 4, 2 minus. Next example, it will convert Mn2 plus, manganese 2 plus to MnO2 in the basic medium. Is it clear? Okay, write down in notes. In notes, write down potassium permanganate is not used. Okay, sometimes question may be asked in your exam, like potassium dichromate can be used in the titration. Okay, titration में हम use करते हैं as a primary standard. But potassium permanganate cannot be used for the titration with HCl. With HCl, you can use other acid, but why you can't use this potassium permanganate with HCl in the titration? Okay, so because this potassium permanganate will oxidize that HCl. It will oxidize that HCl to chlorine. Basically, here this will give you H plus and Cl minus. So in the acidic condition, this potassium permanganate will oxidize the Cl minus to Cl. This Cl minus to Cl2 in acidic condition. Okay, because you can see for the I minus, iodine minus, iodide ion को किसमें convert कर रहा है? I2 minus. Similarly, the chloride ion will convert it to the Cl2. Okay, in the presence of acid, in acidic condition. Okay, so that's why potassium permanganate is not used for titrations, titrations with HCl, with HCl, as it oxidizes, as it oxidizes Cl minus to Cl2. Okay. Okay. Yeah, so that's all about the compounds and transition elements. Okay. So just please revise this, these one like methods of preparation. You should know how to write on the methods. This pH dependence is very important. Okay. So make question like case-based type of question can be asked from here, this part. The structure is not much important. Chemical properties are important, uses are important, right? So just please just go through this. This is important. Okay. Now, coming to the F block elements. Now, as you know, F block elements are known as inner transition elements. Okay, so F block elements are known as inner transition elements. And what is the location of F block elements? So they are basically, they belongs to the group 3. They are basically group 3 elements. Okay, not all the group 3 elements, group 3, and basically F block elements have two series, lanthanoid series, lanthanoid series, and the second one is your actinoid series, actinoid series. Okay, so lanthanoid series basically they are located in group number 3 and period number 6, period number 6. Okay, and this actinoids they are located in the group number, again the group number 3 and period number 7. Okay, so inner transition elements are basically classified into two series, lanthanoids and the actinoids. Okay, now what is lanthanoids? And both they are placed in the bottom of the periodic table. Okay, separately they are placed in the as in the bottom of the periodic table. And this lanthanoid series, again it has a 14 elements, 14 elements which starts from the lanthanum. Following lanthanum, it starts from the cerium, okay, and last till the lutetium, okay, lutetium basically. So lutetium, okay. So cerium atomic number is 58, and it end to the atomic number 71, which is lutetium, right? So these are 14 elements followed by lanthanum. This is a lanthanoids. Now, what about the actinoids? So actinoids are again 14 elements following actinium, which starts from the thorium, okay, and end till lawrencium. This Lr is the lawrencium. Okay, these are the two transition series, lanthanoids and actinoids. Next, okay. So what about the general electronic configuration? So you know very well this lanthanoid series are also known as 4F series. इसे हम 4F series भी कहते हैं and the actinoids are known as 5F series. Okay, because you just fill the electron in the 4F in lanthanoids, and in actinoids you fill the electron in the 5F orbitals. So general electronic configuration of lanthanoids is 6s2 5d from 0 to 1, okay, or basically 4f 1 to 14, 4f 1 to 14. Okay, are you making notes along with me, everyone?
Yes, ma'am.
Okay, so I will give you these notes after this class. Okay, I will share it with you. So general electronic configuration is 6s2 5d 0 to 1, 4f 1 to 14. This is the general electronic configuration. Most stable electronic configuration of lanthanoids are plus 3. Just remember this. Plus 3 oxidation state is the most stable oxidation state of the lanthanoid series. Almost all lanthanoid series exist in this oxidation state. Okay. So, yeah. Atomic size. What about let's see the trends in the atomic size and ionic size of the lanthanoids. So gradually, the atomic size it decreases. Okay, gradual decrease in atomic size from lanthanum to lutetium. Why? Due to the lanthanoid contraction. Okay, because this lanthanoid contraction, you know very well, it is due to the poor shielding effect. Okay, because you know very well what is the order of the shielding effect: S, P, D, and F. So these two, they D block elements, D and F block elements. These two orbitals, D orbitals, F orbitals, they show poor shielding effect. And this F orbitals, they show poorest shielding effect. Okay, so why there is a, because the contraction, there is a lanthanoid contraction starts because before d orbitals you just start filling the electrons in the f orbitals. So due to that the lanthanoid contraction occurs, and due to the poor shielding effect of the f orbitals, क्या होते हैं, there will be a reduce in the size of the atoms. Okay, the size, atomic size reduces. Why? Due to the lanthanoid contraction. The size decreases due to the poor shielding effect. What happens? There will be a more force of attraction between the nucleus and the valence electron. Okay, so because the inner electrons are not capable of uh, to intervene in the path of this force of attraction between the positive, between the nucleus and the electron. Okay, so what happens here? Due to the poorest shielding effect of f orbitals, there will be not as a strong uh, shielding effect as compared to the p and s orbital. Basically, s orbital and p orbital, they show a stronger shielding effect. They just intervene, they just act, the inner electrons uh, act as a shield between this electron, outermost electron, and the nucleus. And due to that, the size increases. There will be a less force of attraction between this nucleus and the electron. Okay, so when the size increases, what happens? The shielding effect decreases. Okay, shielding effect basically increases. So in this case, F block elements, here the shielding effect is very poor. So due to the poor shielding effect, the electrons, outermost electrons, and between the nucleus, there is more force of attraction, a stronger force of attraction you can see. So, and this is due to the lanthanoid contraction. Okay. So you can see a decrease, gradual decrease. अब शो देखते हो lanthanum to lutetium. Okay, so what is the trend of atomic size and ionic size in the lanthanoid? So basically, it decreases from lanthanum to lutetium. And what is the reason? Due to the lanthanoid contraction, due to the poor shielding effect of 4f electrons. Got my point?
Yes.
Okay, so the decrease in size of lanthanum Ln3 plus. Ln basically it is the general symbol for the lanthanoids, Ln. Okay, lanthanoids के लिए हम generally we can just represent it by Ln. So Ln3 plus. Okay, now if the lanthanoids has oxidation state of plus 3, so the decrease in size of Ln3 plus is not very gradual. Okay, see what was the actual trend of atomic size. So actual trend, it basically decreases. But for a specific oxidation state, like plus 3 oxidation state, so the size, basically the decrease in size is not very gradual. Okay, this is not very gradual. Somehow in the between, you will see uh, some irregularities, some irregularities. So just remember, if the atom is neutral, if there is in suppose this is your cerium, okay, your neodymium and your promethium, which is atomic number 61. Okay, if it is a neutral gaseous atom, okay, so its atomic size basically it will increase. Okay, the trend of the size, atomic size will be, it will increase. Sorry, it will decrease, not increase. Okay, decrease होगा due to the lanthanide contraction. But if the oxidation state, suppose oxidation state is plus 3, okay, for PM also, promethium, PM is promethium. So it's again plus 3. So you will not see a gradual decrease. Okay, in some, you will see some irregularities in this trend. Okay, sometimes क्या होगा वो increase होगा. So you will not see the gradual decrease in lanthanum in plus 3 oxidation state. But in the neutral state, you will see the gradual decrease in the atomic size due to the lanthanoid contraction. Okay, next is your oxidation state. What about the oxidation state? So you know lanthanum Ln3 plus is most stable oxidation state. Plus 3 is the most stable oxidation state of the lanthanoids. But 2 plus 2 oxidation state and plus 4 oxidation state also exist. These two also exist, but most stable oxidation state is plus. Okay, yeah, Ce4 plus. Cerium, this is Ce is your cerium. Okay, atomic number is 58. So cerium 4 plus is possible. Why it is possible? Due to the stable 4f0 configuration and inert configuration. Okay, so when you write down the electronic configuration of cerium, first you will write down the cerium electronic configuration. So atomic number is 58. Okay, and after that you will write down the Ce4 plus. So you will see that the 4f0, there are 0 electron in the 4f orbital, and due to the inert configuration Ce4 plus is possible. Cerium 4 plus is again possible. Similarly, your EU2 plus. EU2 plus is your EU is basically europium. Okay, what is EU? EU is your europium. So europium 2 plus is possible. Why? Due to the stable 4f7 configuration. So again, because as we have discussed in the D block elements, transition elements, the half filled and fully filled configuration are most stable. So similarly here in f orbitals, you know how many electrons, maximum number of electrons in the four f orbitals? Yes, Rimdha, maximum number of electrons in the f orbitals. Yeah, who will tell me? For X, there are 2 electrons. Okay, so how many? For P, there are 6 electrons. That's why you just 1s2, 2s2, 2p6. Why you don't